Alright, this first few questions are asking me to graph the parabolas. The first one is given to me in standard form, so in order to graph this, I want to find my vertex. To find the x value of the vertex, remember I use x equals negative b over 2a. My a is 1, my b is negative 4, and my c is 5. So I'm going to plug into the x formula for the vertex. I have negative from the formula, negative 4 from the b value, 2 from the formula, and 1 from the a value. Then I want to simplify. Negative 4 gives me positive 4. 2 times 1 gives me 2. 4 divided by 2 gives me 2. So that's the x value of my coordinate. Now I want to go ahead and find the y value. So I am going to plug in the x value into the equation to get the y value. Okay, then I'm going to type it into my calculator. I have 2 squared minus 4 times 2 plus 5. Then I hit enter. It gives me 1. So my vertex is at 2, 1. Because I have an a value of 1, it just means I go up 1 over 1 for my second point for my parabola, and then I just connect them. Number 2 is given to me in vertex form, so remember that is y equals a times x minus h. Squared plus k, where hk is my vertex. So over here, my vertex is 3, 1. This one has 1/2 as my a value, so what this means is everything is going to be doubled. I take the 2 from the bottom of the fraction. So I'm going to go over 2, up 2. I cannot count 2. Over 2, up 2. And then I connect it to make my parabola. This one again needs me to use the vertex formula, so I'm going to have x equals, this is a, b, c, negative from the formula, negative 4 from the b value, 2 from the formula, 2 from a value, negative 4 gives me positive 4, 2 times 2 gives me 4, 4 divided by 4 gives me 1. Then I want to go ahead and plug in that 1 into x to get my y value of the vertex. Which is 3. So my vertex here is 1, 3. I want to go plot that. And then here, since my a value is 2, what this means is I still go over 1, but this time I go up 2 for the second point. And I do that on both sides. And I connect it, and it's a skinnier than normal parabola. Okay, number 4 wants me to find 3 things. It wants me to find the x-intercepts and the vertex. To find the x-intercepts, I need to factor. And to find the vertex, this is using the vertex formula. So to factor this, I'm looking for what multiplies to 6 and adds to negative 5. This is going to be negative 2 and negative 3. And then I set it equal to 0 when I'm finding the x-intercepts. I take each part, I set it equal to 0. I solve for x. I get x equals 2. Over here I add 3. I get x equals 3. For number 4, this is number 4. For the vertex part of number 4, I want to use that x equals negative b over 2a. So my a is 1, my b is negative 5, and my c is 6. So I have x equals negative 5 over 2 times my a value of 1, which gives me positive 5 over 2. Then I'm going to plug that into my formula. So I have y equals 5/2 squared minus 5 times 5/2 plus 6. Then I'm going to go ahead and type that into the calculator. It gives me a decimal. What I can do is I can go to math, choice 1 is fraction, press enter, and it turns it back into a fraction for me. So it gives me -1/4. So my x coordinate is 5/2, and my y coordinate is -1/4 for my vertex. Okay. Number 5 gives me a quadratic formula, and it wants me to decide if it has a maximum or minimum value. It is positive. The leading coefficient is positive, so that means it's in a U shape. U shapes have the minimum value. Okay. B wants me to find the minimum value, that is the y value of the vertex. C wants me to find where it occurs, that's the x value. So this is y value, x value. I am going to do C first because I'm going to use the vertex formula. So I have A is 3, B is -6, C is -1. I'm going to do x equals negative from the formula, -6 from B, 2 times 3 from my A value. -6 is 6, 2 times 3 is 6, 6 times 1 is 1, 6 divided by 6 is 1. So that is my x value where this occurs. Then to get my maximum or minimum value, I'm going to take the 1 and plug it back into the equation. So I have 3 times 1 squared minus 6 times 1 minus 1. And I want to go ahead and type this into the calculator. I have 3 times 1 squared minus 6 times 1 minus 1, which gives me -4 for my minimum value. Okay, number 6 tells me Sean has 180 feet of fencing. He is going to be using it to make 3 sides of a rectangular garden, with the 4th side being his house. So it's going to look like this. He has 2 x's and 1 length. We want to find a function that gives the area of the garden in square feet in terms of x. So we know area is going to be length times width. In this case, width is represented by x. And then I know he has a total of 180 feet of fencing, which is 2 x's plus L. I want to solve this for L, so I can plug it in there to have only one variable in my area equation. I subtract 2x on both sides. I have L equals 180 minus 2x. I'm going to take this and plug it in for the L in the area function. So I have x times 180 minus 2x. Then I want to go ahead and distribute. And I get 180x minus 2x squared. That is my area function. Then it wants me to find the maximum, or the side length to give the maximum area. This is the x value from the vertex. So I'm going to rewrite the area formula in standard form. I have -2x squared plus 180x. A is -2, B is 180. So I have x equals -180 over 2 times -2, which gives me -180 over -4. I don't know that one off the top of my head. So I'm going to type it in my calculator. -180 divided by -4 gives me 45. So my maximum side length is 45 feet. Then to find the maximum area is the y value of the vertex. So I'm going to plug in 45 into my area equation. I have -2 times 45 squared plus 180 times 45. I want to type that into my calculator. -2 times 45 squared plus 180 times 45 gives me 4,050. Since we're talking area, it's going to be feet squared. Okay. This one wants me to list each zero and state its multiplicity. So first I need to set each factor equal to 0 to find it. So I have x to the 4th equals 0, x minus 2 equals 0, and x plus 1 equals 0. This one, if I take the 4th root of both sides, I get x equals 0. This one has a multiplicity of 4 because of the exponent. Multiplicity of 4. This one, I add 2 to both sides to get x equals 2. The exponent here was 3, so this has a multiplicity of 3. And this one I subtract 1, I get x equals -1. No exponent, so it has a multiplicity of 1. This one wants me to use the rational zeros theorem to list all the possible zeros of the function. Remember, the leading coefficient is q, the constant at the end is p. I'm going to list out all my factors for p. So I have plus or minus 1, and the other factor that goes with 1 is 28, because 1 times 28 gives me 28. I have plus or minus 2, 2 times 14 gives me 28. Then I have 4. 4 times 7 gives me 28. And then 5 and 6 don't work. Then I want to find my factors of q. I have plus and minus 1, plus and minus 6, plus and minus 2. 2 times 3 gives me 6. Then my possible zeros come from taking p and dividing by my q values. So the first set gets divided by 1, so I just rewrite everything from p. Plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 7, plus or minus 14, plus or minus 28. Then the second set comes from taking all of those numbers and dividing by 2. If it gives me a new answer, I write it down. If it's repeated, I don't. So I have 1 divided by 2, which is 1/2. That's a new one. 2 divided by 2 is 1. I already have that. 4 divided by 2 is 2. Have that. 7 divided by 2 is 7/2. That's new. 14 divided by 2 is 7. I have that. 28 divided by 2 is 14. I have that. Then I have 1 divided by 3. 1/3 is new. I have 2 divided by 3. 2/3 is new. 4 divided by 3 is new. 7 divided by 3 is new. 14 divided by 3 is new. 28 divided by 3 is new. Then I have 1 divided by 6, which is new. 2 divided by 6 simplifies to 1/3. I already have that one. 4 divided by 6 simplifies to 2/3. I already have that one. 7 divided by 6 is new. 14 divided by 6 simplifies to 7/3. I already have that one. 28 divided by 6 simplifies to 14/3. I also have that one. So these are my answers. Okay. Number 9 tells me that the function has at least, let's just say 1. Rational zero. Use this fact to find all zeros of the function. So what I first want to do is I want to add up all my coefficients and see if it equals 0. If it equals 0, then it means 1 is one of my factors. I have 1 minus 4 minus 20 plus 48. 1 minus 4 is -3. -3 minus 20 is -23 plus 48 does not equal 0. So I am going ahead to try -1. I am going to write my coefficients. I have 1, -4, -20, 48. First number always goes straight down, which is 1. -1 times 1 is -1. I add down. -4 minus 1 is -5. -5 times 1 is +5. -20 plus 5 is -15. -15 times 1 is +15, which gives me 63. This one doesn't work. Let me cross through it in red. Okay, I'm going to try again. This time I'm going to use 2. One goes down. 2 times 1 is 2. -4 plus 2 is -2. -2 times 2 is -4. -20 plus -4 is -24. -24 48 was positive. -24 times 2 gives me -48, which gives me the 0 I want. This is a factor. I'm going to rewrite this as a quadratic since it'll be easier to factor that than to guess. Remember, when I rewrite it, I go one exponent less than what I started off with, so I had x cubed. When I fill back in, I'm going to fill in with x squared. Minus 2x minus 24 equals 0. I want to factor. I'm looking for what multiplies to -24 and adds to -2. It's going to be -6, +4. Then I'm going to take each of my pieces and set them equal to 0. This one I add 6, I get x equals 6. This one I subtract 4, I get x equals -4. Remember, this 2 that I used over here is a solution, so I should include that. I have x equals 2, x equals 6, x equals -4 as all of my answers. Okay. Number 10 tells me 1 is a 0, and then I'm going to use that to find all the other zeros and then to rewrite f of x as a product of linear factors. So, starting off, I know 1 is a factor. Then I'm going to write my coefficients: 1, -4, -7, 10. Bring down the 1. 1 times 1 is 1. -4 plus 1 is -3. -3 times 1 is -3. -7 plus -10, -3 is -10. -10 times 1 is -10, which adds to 0. I'm going to rewrite this as a quadratic. I have x squared minus 3x minus 10 equals 0. Then what I want to do is I'm looking for what multiplies to -10 and adds up to -3. So it's -5 and +2. Because I'm looking for a product of linear factors, I actually don't need to solve this out. What I'm going to do is I'm going to write f of x. It should have said q of x, by the way. The function was q. Q of x equals, I have x minus 5, x plus 2, that came from me just factoring right now, and then I have this 1. When I write the 1 in, I have it opposite the sign, because remember, when I take it and solve it, it's x equals 1, so to get it back, I subtract it. And this is my final answer here. So I need to pay attention to what the question is asking me for. Okay. Number 11 wants me to write the end behavior of the graphs. On the test, it's not going to have it in math notation, it's going to have it in words. So this one is an odd that's negative. It looks like this. This one is an odd even. It opens down. And this one, I have to add my exponents. I have 1, 2, and 1. That adds up to 4. It's positive, so it's U-shaped. This one goes up, then down. This one goes down and down on both sides. This one goes up and up. Okay. Number 12 wants me to consider the end behavior of this graph. I need to figure out what degree it is. I have 1, 2, 2, so it's 5th degree. And again, it's odd, or it's negative, so it looks like this. This one I'm going to write my end behavior out. So I have as x goes to the left, the graph goes up. Then the second part is as x goes to the right, the graph goes down. It wants me to find each real zero and then say what kind of behavior it has, so goes through or bounces off. I have x plus 3 that I need to solve, x minus 4 that I need to solve, and x plus 1 that I need to solve. So when I subtract 3 on both sides, I get x equals negative 3. That only happened once, so it crosses through the x-axis, through the y-axis. This one, I add 4 to both sides, I get x equals 4. Happened twice, so it touches. This one, I subtract 1, I get x equals negative 1. Also happened twice, so it also touches. C wants me to find the y-intercept. To do that, I take, if there's a negative sign out front, I keep that. Then I take my numbers, and if there's exponents outside, I keep them with it. So I have 3 doesn't have an exponent, negative 4 does, it's a 2, and positive 1 also does, it's also a 2. So then I'm going to go ahead and type this into the calculator. I have negative 3 times negative 4 squared times 1 squared, which gives me negative 48. Then it wants me to graph this function. What I want to do is plot my crossing points for my zeros. So I have negative 3, 4, and negative 1. Then I know it has a 0 of negative 48. My graph counts by, or my graph has 10 squares. I'm going to count by 4s. So that would make this negative 40. Negative 48 would be down here. So I'm going to make a note. Y scale by 4. And then what I need to do is I just need to match this up. So it crosses through the negative 3 and then touches the other 2. So this is going to look something like this. Okay. This one gives me 2 graphs and it wants me to match them up. The first one is degree 3. The second one is degree 5. I am looking to see where it's crossing. So on the second one, I'm going to factor out 3x to the 4th. And I have x plus 2 left over. So this one is crossing at 0, because when I set that equal to 0, it gives me 0. And then this one is crossing at negative 2, or touching. So for the first one, it's crossing at, let me write 3rd degree so we don't get confused. And then it has the x-intercepts at negative 4 and positive 2. So I'm looking for a graph that bounces off at negative 4 because it has an even exponent and goes through positive 2. This one doesn't even go through 4. This one is hard to see, but it's bouncing off of 4 and going through 2. That is exactly what I wanted. So this one is B. This one I need to bounce at 0 because it has an even exponent. This one goes through negative 2. This one bounces at 0 and goes through negative 2. This one also bounces at 0 and goes through negative 2. Notice the difference between these two is this one is more rounded, whereas this one is, this one's more flat, where this one is more rounded. This one is actually my correct solution because I have 4 zeros happening, so it actually stretches. Remember we said earlier in the notes that it stretches when it gets to, when it has more zeros at the same point. So this one is C. Okay, this one gives me a graph and it wants me to answer. It's asking where the function is decreasing. Remember, that's where it has a negative slope. So those two sections I just highlighted are where the graph is decreasing. It's going from negative infinity. This point is about 2.5, and it's on the left side, so it's negative. And then it starts decreasing again at -1 all the way up to +1. Okay, it's asking where it has a local maximum, so that's where it has a high point. That is right here, which is -1, 0. What is the sign of the leading coefficient? Since it's even and going up, that means it has to be positive. D is asking for the possible degree. I have 3 terms, and I know that it's even, so it has to be more than 3. The highest number that is even above, the lowest number that is even above 3 is 4. So it could be 4th degree. Okay. Number 15 wants me to find the domain of each function, f of x and g of x. To find the domain, I take the denominator and I set it not equal to 0 and solve. So I get x squared equals, can't equal square root of -9. If I do this one, I get an imaginary number. That means for f, my domain is everything. Because no matter what I plug in, it'll always work because we're always using real numbers. So my f domain is -infinity to infinity. Then for g, I'm going to take the denominator and set it equal to 0. So I have x squared minus 3x minus 10 equals 0. I want to factor that. I'm looking for what multiplies to -10 and adds up to -3. That's -5 and +2. I take each piece and set it equal to 0. I have x minus 5 equals 0, x plus 2 equals 0. On the first part, I add 5 to both sides. I get x equals, these ones can't equal 0. X can't equal 5. And then over here, I subtract 2. X can't equal -2. It can be any other number, it just can't be those two. So what I'm going to do for my g domain is I'm going to write, it can start from -infinity. The lower of these two numbers is -2. It can't be -2, so I skip that. I'm going to union this with -2 through 5, because it has to stop again at 5, and then it goes to 5 through infinity for the rest. Okay. Number 16 and 17 are a little bit different. It wants you to graph all the asymptotes for the function, but you don't actually have to graph the function. So for 16, I'm going to start by doing my vertical. To do that, that's where the denominator can't be 0. So I have 2x minus 3 can't be 0, and I solve this. I add 3 to both sides. I have 2x can't be 3. Divide both sides by 2. X can't be 3/2 for that one. Okay. Then for my vertical, my horizontal asymptote, I look at my fraction. Since they have the same exponent, they're both x to the first degree, I just take their leading coefficients and divide. So I have y equals 4 divided by 2, which is just 2. So I have my horizontal asymptote at y equals 2. And that's all I need to do for this question. Number 17 works the same way, so I am going to start off by looking for my vertical. I take the denominator and I set it equal to 0. X squared plus 1 can't equal 0 because that's where I'm going to have my asymptote. I subtract 1 on both sides. I have x squared equals negative 1. I take the square root of both sides. I get an imaginary number, so there's nothing to worry about. There's no vertical asymptote. For my horizontal asymptote, notice that the degree of the numerator is less than that of the denominator. When that happens, that means my asymptote is just y equals 0 for the horizontal. And if it was the other way around, I would divide to get a slant asymptote and there would be no horizontal asymptote. Okay. Number 18, my computer did not format that right. It's a fraction, so this was over x minus 2, just to get this look a little cleaner. What I want to do is I first want to graph my horizontal asymptote, which is going to be x minus 2 can't equal 0. I add 2 to both sides. I said horizontal, didn't I? I meant vertical. So x can't equal positive 2. Then this one has a higher exponent on the top, so I want to divide and see if I have a slant. I am going to use synthetic division. I know 2 is the number I'm dividing by. I'm going to write my coefficients out front. I have 1, negative 2, 1. The first one comes down. 2 times 1 is 2. Adds together to 0. 2 times 0 is 0. 1 plus 0 is 1. So I get x plus 1 over x minus 2. This ending part doesn't matter so much. My slant asymptote is y equals x. So I want to graph that. That is through the origin, up 1 over 1. So like that. Then I know, or next what I want to do is I want to find my zeros of the numerator. So I take x squared minus 2x plus 1 and set it equal to 0. I want to factor that. I have x minus 1 times x minus 1 gives me the negative 1's multiplied a positive 1, and they add up to negative 2. So when I go to solve this, I really have x minus 1 equals 0. Then I add 1 to both sides. I get x equals 1 for one of my zeros. Because it's in between two asymptotes, I know it's going to have to curve like this. Then I need to see if the other piece is over here or here. So I am going to plug in a point. I will pick, this is 2, so I'm going to plug in 3. I have 3 squared minus 2 times 3 plus 1 over 3 minus 2. So I'm going to go ahead and type that into my calculator. When I type that into my calculator, I want to make sure my whole numerator is in its own set of parentheses and the denominator is also in its own set of parentheses. So I have 3 squared minus 2 times 3 plus 1 divided by 3 minus 2, which gives me 16. So I have the point 316. That is like off the graph right here, but that's useful because I know it's in this triangular shaped piece, so it's going to look like that. This one wants me to compare the functions and then choose the graph from the choices below. What I want to do is I want to look at the denominators and see where it has asymptotes. This one will have, if I factor, I have x minus 1, x minus 2, because those both multiply to positive 2 and add up to negative 3. If I set those equal to 0, I get x equals 1, x equals 2 for my asymptotes. If I look at my graphs, it's a little tricky to see. This one only has one vertical asymptote, so it's not A. This one is at negative 3 and 3. This one is also at negative 3 and 3. and then this one is at 1 and 2. So it's the only one that has that. So f of x, I'll write this down here, is d. For g, I want to take my denominator and set it equal to 0. It gives me x plus 3, x minus 3. So I know these are the only two that have asymptotes between 3 and negative 3. Notice, if I look at this one, it seems to have a horizontal asymptote. Remember that the horizontal asymptotes happen when I have a higher exponent on the numerator than I have on the denominator. My higher exponent is on the denominator, so I don't have a horizontal asymptote. My asymptote is actually at y equals 0, which C has. So g of x belongs to C.